Section 11.7 is long enough that I almost feel like I should do the video in two parts. Maybe we will. We'll see how it goes. But we're going to solve exponential and logarithmic equations. We'll start with exponential equations and then we'll move to logarithmic equations. For exponential equations, the idea that's going to help us solve things is this. So here's our idea. If we have two things that are equal to each other, for instance, A equals B, if that's true, then log base log base x of A equals a log base x of B. In other words, you can take the log on both sides. So, okay. I mean, it seems like a harmless idea. It's nothing more than what we've done in previous situations with solving an equation. You do the same thing to both sides. This time, we're taking the log on both sides. So what's an example of such an equation? Well, here's your exponential equation. Stuff like number 30. 5 to the x equals 12. What makes this an exponential equation? Can somebody characterize what do you think would make this an exponential equation as opposed to a quadratic equation? Oh, did I copy the wrong one? Which one is it? 7 to the x? Yeah, the variable's in the exponent. So that's what makes it an exponential equation. All right, so we'll call this problem 30-ish then. Our goal still is to figure out what x is. I mean, well, if x was 1, you'd have 5 on the left-hand side. That's not enough. If x is 2, 5 squared is 25. That's too much. So whatever we get for x has to be between 1 and 2. That's all we really know. Well, let's take our advice up here. Let's take the log on both sides. Now, if I don't write anything here, what base logarithm do I understand myself to be using? 10. Does this help? I mean, so I took the log on both sides. It actually looks worse. Is there anything I can do from here? Emma? Well, what about your properties of logs? Do your properties of logs tell you we get anything here? Oh, yeah. There's that parachute rule, right? The x can come out in front. So I get x times a log of 5 equals a log of 12. Okay, so if I divide both sides by log of 5, then I'll have my solution for x. So I get x equals the log of 12 divided by the log of 5. Yay. And that's it. Log of 12 divided by the log of 5. Let's see if we can't calculate that number. So take out your calculators. So type in the log of 5, or excuse me, log of 12, and then you need that right parenthesis. Log of 12 divided by the log of 5. Without that right parenthesis, what your calculator is going to do is it's going to divide 12 by the log of 5 and then take the log of that. You're going to get something much different. Yeah. So let's go back and do it the right way. Now, how do you suppose I could check my answer? Say again? Not multiplication. Yeah, plug in x back into the original equation. Now, there's an easy way to do that. Take 5 and raise it to the power of the answer. So hit the second key, then the enter key. Oops. So 5 raised to the power of the previous answer. So not the second key, then the enter key. It should be the second key, then the opposite key down here. And that should give me 12. Yay. Nailed it. Now, one of the properties of logs that we went through can actually help you out in a problem like this. Let me go back and do this a different way. What if instead of taking the log base 10, what if I took the log base 5 on both sides? What difference would that make? You could, and I'll do this in kind of 2 steps instead of 1, you could say, well, that's x times log base 5 of 5 equals a log base 5 of 12. What power of 5 gives me 5? 1. So this is really a 1 here. So x is log base 5 of 12. Now, there's a change the base formula that I gave you on your most recent test, and I'll give it to you on the next test if you need it, and on the final. But the change the base formula basically says that to calculate log base 5 of 12, I would do log of 12 divided by log of 5. So I get the same thing. So you get the same thing either way, and that's good. It's reassuring. Let's try some more, unless there's some specific questions on this one. Yes, sir. Thanks, Kyle. Yeah, you can use either one. Now, sometimes what we'll eventually see is you have, variables on both sides, and you're just going to have to pick one log. You're not going to be able to get the nice cancellation on both sides, but we'll do the best we can. Anything else? Let's try problem number 32. You guys got me nervous. I was checking to make sure I got the right problem this time. I do. So problem 32, 5 to the x plus 1 equals 3. Suggestions, how would we solve it? Well, let's just take the log on both sides. Log of 5 to the x plus 1 equals a log of 3. All right. What can I do from here? Kennedy, suggestions? Well said. X plus 1 is going to come out front. Now let's do something for ourselves just to be really careful here. Let's put parentheses around that x plus 1. Because when it comes out in front, it's still going to come out in front with those parentheses. So x plus 1 times a log of 5 equals a log of 3. What you're going to see from me is a steady increase in the difficulty and the nuances of these different types of problems. So here, we're not quite done solving for x. There's a couple different things you can do. What catches your attention? If you wanted to get x by itself, what would you do? I had a couple. Divide by log of 5? Absolutely. All right, so let's divide both sides by log of 5. That gives me x plus 1 equals log of 3 divided by the log of 5. By the way, there's no simplification or anything we can do with that there. It's just log of 3 divided by log of 5 and leave it like that. Almost done. What's our last step? Subtract 1. So x equals the log of 3 divided by the log of 5 minus 1. Now, for some problems on the test, I might just ask you to calculate an expression like this to say, hey, tell me what decimal value you get. So go ahead. See if you can't get a decimal value for that. I'm going to use the fancy-dancy capabilities of this calculator and hit the alpha key, then the y equals key, then press 1. That gives me a nice fraction, and I don't have to worry so much about the parentheses as much. So I want the log of 3, and then hit the down arrow to get into the denominator, divided by the log of 5. Right arrow gets you out of there, minus 1. Before I hit the enter key, what did you guys get? Minus 0.3 something? All right. Good deal. Again, you can check this. Probably the easiest way to check this is to hit the store button here and store that number in X, which is right up here. Then press enter. It's just going to respond like that. But now we can type in the equation. 5 raised to the power of x plus 1. And I get 3. So nice. It works. You can check all your answers. Yes, ma'am?
When I tried to check it, like how we did kind of for number 30, how we just like hit second and then put the answer back in there, it gave me something different.
Okay, so let me go back a couple steps here. So this is my previous answer. If I wanted to check this without doing the store bit, I could do 5 raised to the power of second answer plus 1. That should also work out. Now, depending on your calculator, if you hit 5 and then raise to the power, if it gives you a little caret, if you do 5 raised to the power, if your calculator is giving you the caret, then you're going to have to put a left parenthesis, answer plus 1 right parenthesis. You have to put that all in parentheses. Otherwise, it's just going to take 5 to that power and then add 1 to that whole total. So it's going to do something different. All right? Give that a try, and if you're not having success, let me know. Let's keep going. Problem number 34. Six to the x equals 7 to the x plus 4. 7 to the x minus 4. Thank you. Again, the level of difficulty is going to kind of increase. It's increasing because we've got the variable on two different sides here. You could take log base 6 or log base 7. That'll help out a little bit. But in the end, you're still going to be stuck with the fact that you can't get rid of both of these with the right logarithm. We probably could have in the last one, but not here. So I'm just going to take log base 10 on both sides. So log of 6 to the x equals log of 7 to the x minus 4. Norman, what can I do from here? What should I do from here? All right, so the x here is going to come out in front. X minus 4 is going to come out in front. Make sure you take that x minus 4 out with parentheses. X minus 4 log of 7. There's going to be a couple tricks in this problem. Just make sure you catch on to these tricks. Certainly something like this would be a harder question for an exam. The first trick is right here. I need to distribute. Distribute the log of 7. So it's going to be x log of 6 equals x log of 7 minus 4 times the log of 7. So we distributed. Why did I distribute? Well, I need to be able to move around this term in x. I need to be able to get the x's on one side. So there's a couple ways you could do this. It kind of depends on you. An easy way to do this, bless you squared, wow. All right, so he's allergic to working with these things. I don't blame him. Let's just move the x log 7 term to the left-hand side. What does that do for me? Well, it gets both x's on the same side, right? Now, what's the advantage of that? Well, at least I get both x's on the same side, but I still need to kind of whittle this down. I need to get them together. Is there anything I can do to try and further get the x by itself? Wow, good job. You can factor this. X is GCF, so I can factor that out. So you get x log of 6 minus log of 7. You can't subtract these. You can't get the log of -1, for instance. That's it. This is as far as we can go with this one. Unless you start using your quotient rules and stuff like that. But we're almost done. What's the last thing I need to do to solve? Excellent. This is getting multiplied by this term. To undo a multiplication, we'll do division. X equals -4 log of 7 divided by log of 6 minus log of 7. Quite often on exams, I give problems to people to calculate these kinds of things. So we'll go over that in a second. First things first, though, let's look back at this problem. There was two steps that were crucial. The first one was here, where you had to distribute. That was one very important step. And the second step that was crucial was down here, where we had to factor out the GCF. So both of those were important. The rest was just a little bit of work with our logs to finally end up with this thing down here. Now suppose you're stuck actually trying to calculate a decimal value. Go ahead, see what you can get as a decimal value for this one. If you have a calculator that allows you to do that numerator-denominator trick, the math print, as Texas Instrument calls it, then use it. Definitely will help you out on something like this. I don't know yet. Yeah, I don't know. Let me see. Just a second. Not really big. I'm getting something that's 2 digits. I don't regard this as being very big. Okay. In that sense, yeah. Okay, so what are you guys getting? -5? -5.11. 50.49. What else? -4.874. 7, 4. Okay, what else? Negative 5.18.
Yeah, that's what mine was.
A couple people got negative 5.18. Rachel, what'd you get?
50.49.
50.49. So a couple for this one, a couple for this one. Anything else? All right. So let's see who's right. Now, if you don't have that fancy math print, what you would have to do to enter this in your calculator is type in negative 4 log of 7. Now, log of 7, when you type in the log, it's going to give you a left parenthesis. You have to hit a right parenthesis. Divided by this denominator. And for that denominator, you need to put in parentheses again. So a left parenthesis for denominator, then log, left parenthesis again of 6, right parenthesis for the log, minus log of left parenthesis for the log, right parenthesis for the log, and a right parenthesis for the denominator. So unless you have that fancy math print, this is how you would have to type it in. If you have that math print, then it removes you from having to type in quite so much stuff. Let me type it in the way I just showed. Negative 4 log of 7 divided by left parenthesis log of 6, right parenthesis minus log of 7, and then 2 right parentheses. So 50.49 is our winner. There's a couple other things you can do to make your life easier if you're stuck trying to calculate this. And it doesn't necessarily involve having to have a fancy calculator or a calculator with some fancy capabilities. The first thing I'm going to do is I'm going to use my quotient rule in the denominator. I'm just going to write that as the log of something else. What's my quotient rule say about this term in the denominator? No. But I appreciate the effort. Log of 6 minus log of 7 is the log of 6 over 7. Let's look up in the numerator. What if I took the 4 and put it up here? I'd have minus the log of 7 to the 4th power. 7 to the 4th power is 2,401. So with a little bit of work, I can rework the total. I can rework the expression. And I think it's going to be easier to plug this into my calculator as opposed to what I had to do up here. Minus log of 2401 divided by log of 6 divided by 7. Yeah?
Why wouldn't you bring the negative of the 4?
I could. I could. Yeah. I just didn't want to deal with a fraction, so that's why I didn't bring the negative. But if you did bring the negative, you could make that the log of 1 over 2,401 divided by the log of 6 over 7. So here you don't have to deal with a negative, but you do have to deal with a fraction. I just didn't want to deal with a fraction. So that's why I only brought the exponent. But it's a good question. I probably should have said something. Let's keep going. I know this is difficult stuff, but try and stay engaged, because eventually you're going to have to do this yourself in here, and there's a chance for extra credit, and on a test coming to you real soon. So definitely want to make sure you know this stuff. It's not easy, I understand that, but fortunately for you, entertaining and charismatic, so you got that going for you, which is nice. Why are you giving me such a serious look? Yeah. It's like the English teacher gets mad at a student for texting and says, "You Give me two pronouns. The teacher said, or the student says, who? Me? All right. Good man. All right. Let's keep going with. Let's see. I got problem 22 listed. Let me just take a quick look at problem 22. Yeah, let's back off for a little bit. Do a couple easier problems. Maybe get you back into the swing of things. I know that last one was tough. Problem 22. 3 to the x plus 1 equals 27. Let's just stick with what we've been doing, which is taking logs on both sides. But let me go back to something we did with the first problem, which was to take log of a particular base. What base logarithm do you think I can take or should take with this one? 3. And I'm going to get an added bonus in this one. Now let me show you yet another shortcut on this stuff. The first time we did it, I did it in 2 steps. We can actually do it in 1. The logarithm and the exponential functions are inverse operations of each other. When I do one and then the other, it's like squaring something and then taking the square root. You get back to where you started. These two cancel each other out, and I get x plus 1. Someone help me out on the right-hand side. Can anyone tell me what the log base 3 of 27 is? 3. Wow. Isn't that special? What does x equal? 2. And you can check that real easily, right? 2 plus 1 is 3. 3 cubed is 27. Cool. Works. Yes?
So, I know I log base 3 of 27. If you do that, you have to do it to the opposite side also.
Yeah, you have to take the same base of logs on both sides. So it's a great question. For instance, on problem 34, I couldn't do the log base 6 on one side and the log base 7 on the other side. It has to be base 10 on both sides, or base 6 on both sides, or whatever the case may be. But yeah, you have to take the same base log on both sides. Anything else on 22? Why don't you try problem number 24? Eight to the negative 2x plus 1 equals 1 over 64. My suggestion to you is take the log base what on both sides? Base 8. And the right-hand side should simplify pretty nicely. Now, if you need to, there's a change of base formula. If you needed to calculate, a log of a different base, log base a of x is the same as a log of x divided by the log of a. And of course, the base I'm understanding to use here is 10. So if you need that change of base formula, there it is. Remind me, and I will make sure that you have that on your next test and the final.